Hey guys, sorry I couldn't make it today. I'm just a little under the weather. I didn't want you guys to lose the day though, so I put together a couple things for you guys to work on, and I just want to make sure that you guys are getting this parallelogram stuff down. So, what we're gonna do is I have your warm up here. Didn't print them out today, so you're gonna have to grab a piece of paper. There's paper in the paper bin. All right, and what you guys will do is work on these problems for the next couple minutes. Okay, I'd like you guys to try to solve them. Feel free to look at your notes from yesterday that lay out those different theorems and uh, postulates that we've talked about, and make sure that you're ready to go in a couple minutes. At this time, I'm going to ask the instructor to pause the class while you guys work on these problems. All right, so hopefully that was enough time for you guys to kind of work on these, and I'm going to walk through them one by one for you guys and just kind of show you exactly how to solve these, okay? So the first one we're going to look at is the one from yesterday's exit ticket, the one that a lot of us struggled with, okay? So what I want you guys to do is find what we know based on those theorems. So hopefully, based upon those theorems that we looked at yesterday, you remember that these bisects in a parallelogram, these diagonals in a parallelogram bisect each other, meaning that they cut each other exactly in half. Why is that significant, you ask? That's significant because what we now know is we now know that 2f minus 5 equals 5f minus 17. All right, so sorry about the writing here. Kind of stay with me with what I'm saying, and I'll try to clean up the writing a little bit. All right, in fact, I'm going to rewrite that real quick. So give me a second as I get used to the pen here, okay? So we know that 2f minus 5 equals 5f minus 17. All right. So what my next step is pretty straightforward and simple, right? I know those two are equal to each other. I want to look for combining like terms, which I don't have in this example. So my next step is to isolate x. And I forgot to write an f here. We'll mark that in real quick. All right, so there's that f there. All right, so I know that probably want to subtract that 2f from this side, so we'll start with that. Subtract 2f from both sides, get a negative 5 as these cross out, equals 3f minus 17. The next step is to add 17 to both sides, and you're left with 12 equals 3f. So now that you have 12 equals 3f, you know pretty simply to divide both sides by 3, and you should come up with f equals 4. But you're not done. You still have a variable in there in g. So it's important that we take a moment and look to solve for g. All right, we already have that equation. It's f plus 2 equals g based on our same diagonal theorem. So what we'll do is we'll just substitute in. So for f, we're going to put the 4 that we found, add 2 to it, equals our lowercase g. All right, 4 plus 2 is 6. All right, 6 equals g. And now you have successfully solved this equation. Looking at the next one, which was your first one today, we're kind of going a little bit backwards in this, and we need to remember back to our angle postulate, which says that two adjacent angles equal the sum of the larger angles. So when we look at the whole angle E, we can see angle DEC plus CEF add up to each other to equal the whole angle of E, which is important because when we start to look at this, we need to remember that our consecutive angles equal 180. So two consecutive angles add up to the sum of 180 degrees. So the easy way for us to write this is 42x plus 1 plus 41 plus 54 equals 180 degrees. So what we're going to look at next is just combining our like terms. As you guys know, I love to underline, to make note, and show you guys where our like terms are. Okay, so that 42x is all by its lonesome on that side, so we're not going to do much with that. But what we can do is add that 41 and that 54 and that 1 together. So to make it easier, I'm going to add that 1 to 42 right away, and to 41, which will give us 42, and then that 42 to the 54, which would give us 96. So I'm going to rewrite this problem as 42x plus 96 equals 180. My next step is isolate x, get x by itself, subtract 96 from both sides. I have 42x equals 84. Divide 42 to continue that isolation of x. Ultimately, we want to get x by itself. 84 divided by 42 gives us 2. We have solved that equation successfully. Right? So 42 plus 1, 42 times 2 plus 1 is 85. And then our 41 plus our 54 is 95. 85 plus 95 equals 180, and our problem checks out. We're good to go. Looking at the last one, some algebra, a little algebra review here. All right, our first step is going to be distribute. So what we're going to do is distribute what's on the outside of the parentheses to what's inside the parentheses. So we'll have a negative 8v as we distribute that. A negative 8 times a negative 3 is going to give us a positive 24 minus 6 equals minus 6 minus 4v. All right, time to combine like terms again. I've got these two on this side, and that's it. Quickly, I can say if I have a positive 24 and I take 6 away from it, I'm left with 18. So 8v plus 18 equals a negative 6 minus 4v. Now I kind of left up on what I want to do here. There's a couple different ways you can do. You can add 8v to both sides, or you can add 6 to both sides and kind of work your way there. I'm going to choose to add 6 to both sides. You can do it the other way and you'll come up with the exact same answer, but I found this way easier for me to work with. So here's negative 8v plus 24 equals a minus 4v. All right, I want to add 8v to both sides. Left with 24 equals 4v. I want to isolate that v even further, so we're going to go 4v equals 24 just to rewrite to give me some more space. Divide by 4, divide by 4. Left with v equals 6. And that's how you would solve that simple algebraic expression. So now that we get going, I just want to kind of show you guys the theorems again and talk about them briefly, and then I want to get you guys going and practice a little bit. So follow along with me, all right? So the first theorem that we know is that quadrilaterals have a measure of 360 degrees. Now this isn't parallelograms particularly, but parallelograms are part of the quadrilateral family, like squares, like rectangles, like trapezoids. So what we want to make sure we see is we want to remember that anytime we see a square, rectangle, parallelogram, trapezoid, the interior angle is going to equal 360 degrees. The next theorem we looked at was if we have opposite sides, the opposite sides of a parallelogram are congruent. They're equal to each other. So if we said that PQ was 6, automatically RS is also going to be 6. If we said QR is 15, automatically PS is also going to be 15. Just to kind of help. Coming up next, we'll take a look at theorem 6.3, which is if a quadrilateral is a parallelogram, then its opposite angles are congruent. So we're talking about P and R here. We're talking about Q and S as well. So what we see with that is as we walk through this, what we're talking about is we're talking about those opposite angles being congruent. Q is going to equal S and P is going to equal R. So if you have, say, Q as 100 degrees, it's an obtuse angle, and R, an acute angle, is 80 degrees, we know that those two are going to be congruent to the opposite side. So what we're still going to see is we're still going to see our parallelogram interior angles equal 360. Q is going to be 100, S is going to be 100, R is going to be 80, and P is going to be 80. And that's what our opposite angles are. Our consecutive angles, or angles next to each other, are supplementary. They add up to 180 degrees total. So if P, again, is we'll say 70 this time, we know that S is going to be 120. And we can prove that by saying 70 plus S equals 180. Subtract 70 from both sides, and I did that wrong. Good thing I tried to show you there. Equal minus 110 from both sides. S is going to equal 110 degrees. And that's how you could prove that really quickly. Last but not least is our theorem about our bisect, our diagonals that bisect. So when we have diagonals that bisect, we automatically know, because of the word bisect, that they're going to be congruent to each other. So we know QM is going to be congruent to SM, and MR is going to be congruent to PM. And we know that to be true in parallelograms, and that will assist us in solving a few of these equations, which I want you guys to try. At this time, I'm going to ask the instructor to pause the video. All right, so hopefully you guys had a chance to try to solve this. It's a pretty quick one for you. We know, based on our theorem about opposite sides, and I'm going to write that here. That's going to be on your work today. I want to know that you know the theorems. I'd like you to write opposite sides or opposite angles or consecutive angles or whatever it's going to be on your work. And I know that 15 is going to equal 2x minus 9. So my next step is to isolate x. I want to add 9 to both sides. We have 24 equals 2x, right? Isolate x again, x equals 12. And we have now solved that equation because of our opposite side theorem. Next, I'd like you to try this one as well. At this time, I'm going to ask the instructor to pause the video. Awesome. Hopefully you had a time to make sure that you got this and practice it. But again, we're going to use that opposite sides theorem. All right, and we know that 3x minus 2 is going to equal 2x plus 3. So next step is add 2 to both sides because we're trying to get x by itself. 3x equals, crosses out, 2x plus 5. Subtract 2x from both sides, cancels out. Left with x equals 5. Now you haven't solved this one yet, but we have found what x is. Now they're asking us in the question to find side wx. So what we're going to do is plug that in. So 2 times 5 plus 3 equals wx. All right, we don't know about y and z though. I made a funny. 10 plus 3 equals wx. 13 equals wx. It's really important that you look what the question's asking you and use that substitution property once you find that x. What you're going to have to do on a couple of them, like we had to do on our warm-up, is substitute an answer into another variable question based on a different theorem to solve that theorem, or to solve the variables in that parallelogram. All right, I'd like to do this one. It's got the diagonals in it. I thought it would be a little bit tougher. They give us the entire length here of RT, so we know that these two are congruent and they bisect. So we can take RT, which is 14, we could divide that to find TG and GR, okay? So now that we know that each of these are 7, we can take our GT equation and set it equal to 7 because we know the total length there. So we have 3x minus 2 equals 7. Add 2 to both sides, add 2 to both sides. 3x equals 9. Divide by 3, x equals 3. All right, so hopefully you guys followed along with me on this one to make sure that we got this kind of down. I have an assignment for you. It's 16 questions long. I would like you to explain the theorem that you're using for each one to assure that you are getting your stuff done and ready to go. If you guys have questions, then we're going to have to wait until Friday and I get back in the class. So again, thanks for watching. Be on your best behavior. I don't want to hear any negative comments about you from your instructor today. So please be on your best behavior. Give this a shot. Do what you know. Try what you don't know. And if you're still stumped, we'll talk about it on Friday. All right. Again, sorry for not being there. I hope you guys have a wonderful day, and I hope you guys knock the ECA out of the park 8th hour. All right. Take care, guys.